Hi guys, so today we're going to be looking at the final exam review part 1. So for the final exam review, we're going to go over fractions first. Let's start off with adding and subtracting fractions, and then multiplying, and then dividing. So right here, we're being asked to subtract 3 over 4 minus 8 over 9. If I want to do this, the first thing that I want to do is to make sure that my denominators are exactly the same. The best way to do this is to multiply both sides by its opposite denominator. So I'm going to multiply the 3 over 4 by 9, and then I'm going to multiply the 8 over 9 by 4. When I do that, I'm left with 27 over 36, subtracting with 32 over 36. And so because I multiply both sides by its opposite denominator, now we have the same denominator provided to us. So then from there, all I'm going to do now is I'm going to keep the denominator the same and then subtract the 27 minus 32. So we have negative 32 and a positive 27. Our answer is going to come out negative since the 32 is bigger than the 27. And I'm going to be subtracting them from each other. So this would be 12, this turns into a 2, and we're left with negative 5. So we get here negative 5 over 36. And because they're both not able to simplify, that would be my final answer. Okay. Cool. Let's look at the other one. So the other one here that we have is, let's see, we have here multiplying fractions, where we're asked to multiply 2, 3 over 5 times 3, 1 over 4. So if I'm going to multiply this, I need to start off by changing these fractions, which are mixed fractions, because of the fact that they have a whole number, and I want to change them into an improper fraction. So that means that I need to multiply the 2 times 5 and then add by 3. 2 times 5, that equals to 10. 10 plus 3, that equals to 13. So I get here 13, and I keep the denominator the same, so I get 13 over 5 times, over here we have 3 times 4, that would be 12, plus 1 equals to 13 again. And then again, we just keep the denominator the same. So from there, the difference between adding and subtracting fractions and multiplying them is that I could just multiply across from the top and the bottom. When I do that, 13 times 13, that equals to 169. 5 times 4 equals to 20. And then sometimes they may ask you to change it back into a mixed fraction. So if that's the case here, I'm going to find out how many times 20 can go into 169. If I try out 20 times 8, that will give me 160. And so right here, if I have 160, my remainder is 9. So from this, I can identify what my whole number is going to be, which is going to be the 8. So 8 is our whole number. The remainder is always going to be my numerator on the fraction. Oops, let me make that look better. That's a 9. And then, whatever my denominator was originally, which is shown right here, my 20, that will continue to be my denominator for the new mixed fraction as well. And so my answer is going to be 8, 9 over 12. Okay. Let's look at dividing fractions. So again, I want them all to be in a improper fraction. So with the 6, if you look at 6, we can change this into a fraction. The fraction format of a whole number is 6, or the number over 1. It's always going to be over 1. So we have here 6 over 1. On the other side, multiply 2 times 3, that equals to 6, plus 2 equals to 8. So right here we have 8 over 3, and it's being divided. Now, whenever we're dividing fractions, we have to remember to always change the division sign into multiplication, and to always flip the fraction so that we have, instead of 8 over 3, we have now 3 over 8. Whatever the fraction is on the left side stays the same. So from here, I'm going to multiply 6 times 3 over 1 times 8. 6 times 3 equals to 18. 1 times 8 equals to 8. Again, if I want to find out what the mixed fraction of this is, I'm going to have here 8, and then 18 goes in the inside. I could use 2. 2 times 8 equals to 16, and my remainder is going to be 2. So my whole number is 2, my remainder is going to be my numerator, and my denominator stays as 8. Then from there, I see here that I could simplify the 2 and the 8 by dividing both of them by 2. So as my answer, I get here 2, 1 over 4. Okay. Cool. Alright, so let's try out the next one. Let me clear this, and then let's move on to the next one, which is decimals. So right here, we're asked to add and subtract decimals, multiply and divide decimals as well. Let's start off with the adding and subtracting decimals. So try to do this problem on your own first. Alright, so if we're adding and subtracting decimals, right here, we're being asked to add 23.57 plus 65.12. If I'm going to do this, I want to do it vertically. We have here 23.57, and then the important part is to keep the decimal points aligned with each other, no matter what. So we get here on the left side 65, on the right is the 12, and we're adding them together. And a nice way to do it is to highlight the back so that you know what's aligning with what. So right here, we have 2 plus 7, that equals to 9. 5 plus 1 equals to 6. Bring down the decimal point. 3 plus 5 equals to 8, and 2 plus 6 equals to 8. So as our answer, we get 88.69. Let's look at multiplying decimals. Right here we have 1.2 multiplying with 5.8. Best way to do this is to ignore the decimal points for now. So instead of writing it with the decimal points, let's leave the decimal points out at the moment and try to find out what 12 multiplied by 58 would be. So right here, I'm going to start off by multiplying 8 times 2 and then 8 times 1. 8 times 2, that equals to 16. 8 times 1 plus 7 equals to 7. Then I'm going to add in an extra 0. From there, I'm going to multiply 5 times 2 and 5 times 1. 5 times 2, that equals to 10. 5 times 1 equals to 5, plus 1 equals to 6. So from there, I'm going to add these two together. We get 6, 7, and 6. So here is 676. Now once I do that, I need to still add in my decimal points. So normally for whole numbers, well, we always start with whole numbers with a decimal on the right side. And we want to see how many times it's moved to the left. So for the top number, it moves to the left once. And then for the bottom number, it moves to the left once as well. So I'm going to add those two movements onto my new answer. I'm going to move it twice then, since we moved it once over here and moved it once over here. So when I move it twice, I get my answer, which is 6.76. Okay. Last one we're looking at is dividing decimals. Right here, I'm going to create the formula where I'm going to use in and out. So if you remember, in and out helps us identify what's going to go on the inside of the division sign and what's going to go on the outside. Inside is going to be the 44.46. On the outside is our 1.3. So I'm going to get our denominator, and I want to make sure it turns into a whole number. So I'm going to move the decimal point once to the right. If I do that to that one, I have to also do it to the other number as well. So my new equation is going to be 13, and over here is going to be 444.6. So from there, I'm going to find out what my number is. We can't use 4, it's too small, so we can go bigger to 44. 13 times 3, that would give us 9. This will be 39. So right here, you can use 39. 44 minus 39, this would turn into a 14. This would turn into a 3. We get 5. Drop down the 4. I could use 4. That would give me, that would be 12. 4, this would be a 5, so we get here 52. So 52 minus 4 gives me 26. And then since I'm bringing down the 6 after the decimal point, that means I need to bring up that decimal point up here as well. And then I can bring down the 6. So when I bring down the 6, I have 26. I know that 13 times 2, that equals to 26. So my answer here is going to be 34.2. Cool. Okay, let me clear it. And then let's continue on to exponents. So I'm going to give you time to try this out on your own. You're going to be asked to simplify 4 to the power of 3. What would this equal to? Alright, so whenever we're dealing with exponents, the exponent always tells us how many times are repeating a number. So it tells us how many times I am repeating a number. And whatever our base number is, that's always going to tell us what number is being repeated. Being repeated. So since we have 4 to the power of 3, that means that 4 is going to be repeated, and it's going to be repeated 3 times. So we have 4 times 4 times 4. So 4 times 4, that equals to 16. Still need to multiply by one more 4. 16 times 4, that equals to 24. This would be 64. So our answer here is 64. Cool. Let's look at this one over here. This one is asking us to simplify -2 to the power of 5. So again, I'm going to be repeating -2 5 times. 1, 2, 3, 4, and 5. If I'm repeating it 5 times, then -2 times -2, that equals to +4. Negative 2 times negative 2 still equals to positive 4. And I still have one more, negative 2. 4 times 4 equals to 16 times negative 2. And 16 times negative 2. We'll leave the negative sign out for now. And I'll just leave it showing right here that we'll have a negative sign. 16 times 2, that equals to 12, 32. So we get as our answer negative 32. Cool. Last one is simplifying 4 over 7 to the power 2. So again, I'm going to keep it so that whatever is in the inside of the base is being repeated, and we're repeating it twice because we have the exponent of 2. So from here, we get 4 times 4 over 7 times 7. 4 times 4 equals to 16. 7 times 7, that equals to 49. And since there's no other way to simplify, that would be the end of our answer. Cool. So let me clear this. And then let's look at the PEDMAS rule. So PEDMAS, if you remember, we always solve an equation by starting off with solving the parentheses first. Then we go to the exponents. We do any division and multiplication. Now, the important part with division and multiplication is that whatever is on the left side is solved first, and then you go to the right. Same thing goes for addition and subtraction. Whatever is on the left side goes first, right goes last. So if I look at this problem right here, we're being asked to simplify 4 times 3 minus 9 plus 12 times 3. I'm going to start off with the parentheses first. So 3 minus 9, that equals to negative 6. Keeping the parentheses here, and the 4 plus 12 times 3. Now, whenever you have a number that is next to parentheses, we can automatically assume that there is an imaginary multiplication sign here. So since we have a multiplication, that one goes first, and it's on the left side, so we want to make sure to complete that one. So right here, 4 times negative 6, that equals to negative 24, plus 12 times 3. Multiplication still goes before addition, so I'm going to combine the 12 and the 3. 12 times 3, that equals to 36. And now I have here negative 24 and positive 36. So 36 minus 24. That's still going to come out to a positive answer because of the fact that the 36 is bigger than 24. And then we get here 2. This turns into a 1. We get as our answer positive 12. Cool. Last one is simplifying negative 11 minus 26 divided by 2 over 2 times 3. So whenever we have a fraction, I always want to start off with solving whatever's on top first and then on the bottom. On the top, we have, we have here negative 11 minus 26 divided by 2. I want to start off by dealing with division first because remember, division comes before any addition or subtraction. Negative 26 divided by 2, that would equal to a negative answer, and it would be 13. And I'm going to drop down that negative 11. And then over here, negative 11 and negative 13. Since they're both negative, we're going to get a negative answer. And since it's a negative answer, subtracting with our it's a negative answer and another a negative answer. It's kind of like saying I owe you $11 and then I owe you another $13. So in a sense, we are increasing. So 11 plus 13, that equals to 24. So we get here negative 24. Now we got this top part, which is 24, or sorry, not 24, but negative 24. We still need to find out what the bottom is. The bottom here is just 2 times 3, that just equals to 6. So From there, we can write our new equation, which is negative 24 over 6. And then I could simplify both of them by dividing by 6. If I divide both of them by 6, I get as my answer negative 4 over 1. And then that just becomes negative 4. Because whenever you have a fraction with the denominator is 1, we can always change it back into the whole number, negative 4. Cool. Let me clear this. And let's go to the last one, which is conversions. So try out this problem on your own. It's asking you what is the correct way to express 42% as a fraction. I'll give you a few minutes to try this out on your own first. So if I want to change this into a fraction, I have here 42%. I always know that a fraction for a percentage always has a denominator of 100, no matter what. And whatever the number is on top is going to be on top of my fraction. So from there, if we have 42 divided by 100, I want to simplify the 42 and the 100. I know that both of them can be divided by 2. If I divide both of them by 2, I get 21 over 50. And since there's no way to divide them both by another number, that would be my final answer. The other question is asking for percents as decimals. What is the correct way to express 2.3 as a decimal? If we have 2.3% and I want to change it into a decimal point, the rule is that whenever you're changing into a decimal point, you gotta get the decimal and move it to the left twice. Now, as you can see, we have an empty spot right here, so I'm just gonna add a 0 in there. And so my new answer or new number is going to be 0.023. Cool. Last ones are scientific notation. So whenever we're asked to use scientific notation, we're going to have a number multiplying with 10 to the power of something. In this case, our number is huge. We are having 18,000, and we're trying to change that. So right here is our 18. I'm going to place the 18 on the left side. And then based off of how many zeros we have 3 zeros here. That's going to be on the top. So since there's 1, 2, 3 zeros, I'm going to have 10 to the power of 3. Over here is a little different because of the fact that we have a decimal point. So if we have a decimal point, I want to start off with the same format of something times 10 to the power of something. So with this decimal, if I were to start off from the right side and move it all the way to the left, it would have to move it 1, 2, 3, 4, 5 times. So I would have to move that decimal 5 times to the left. 1, 2, 3, 4, 5. So that means that if I'm moving it to the left, I need to write a negative sign. And since it's moved 5 times, I have to put -5. Whatever this number is on this side is going to go in my left side over here. We have here 34. And that would be my final answer. Okay. So hopefully this helped. Good luck.